Okay, we've made it to 7-8, using radicals to solve quadratic equations. All right, this is page 268 or page 274, depending on your textbook. Okay, so if we start reading here, it says the process of completing the square, and it refers to here to page 232, or it might be page 238, depending on your textbook, can also be employed in solving quadratic equations. Study carefully the following parallel treatment. All right, so you can certainly go back to that page to review completing the square. We can also see its process just right here. Okay, so on the left is we could say a practical example. On the right is the general case that we could use. Okay. All right, so here we have 3x squared plus 10x plus 2 equals 0. And this is a circumstance where we are unable to factor 3x squared plus 10x plus 2. All right, so we're unable to factor that with integers or whatever. So what do? Well, we can use what's called completing the square. And to complete the square, the first thing we do is we divide by the coefficient on the x squared term. That's why there's that 3 not equal to 0, or on the right-hand side over here, there's assume a does not equal 0, right? Because if the coefficient on the x squared term is 0, you can't divide by 0, right? Obviously, if it was 0, there wouldn't be an x squared term, and you wouldn't be involved in completing the square. Okay. Okay, so notice what happened here. We divided by 3. That made 3x squared divided by 3 is just x squared. Now we have 10/3 x plus 2/3 equals 0. Okay, so now we take this constant term and we move it to the other side, right? So it's negative 2/3, right? Crosses the equal sign, changes its sign. Okay, now what are we going to do? Well, we're going to what are we going to do? We're going to use our magic machine, right? We're going to use our magic machine, and let's see, we're going to have we're going to have 1/2. I'm going to have to move this out of the way. Our magic machine is that we take 1/2 times b over a, and that's squared. Okay? So notice, whoops, I wanted to write that so it was still visible, right? Now I'm not even writing that. Let me try it again. 1/2 times b over a squared. This is what I call the magic machine. Okay. So let's bring back our digital textbook. Okay, so notice here, the 10/3 x, that's the b over a. See the b over a right there. Okay. Remember your original terms are in the order a, b, c. Okay. So b refers to the second term, and it's b over a because we divided by the a, the coefficient on the first term, the x squared term. So we're going to take b over a, in this case 10/3, and we're going to place it into our magic machine. Now you'll notice that we ended up with this 5/3 right here. Well, how did that happen? Well, let's take our 10/3 and let's turn this into 1/2 times 10/3 squared, right? We can factor. There's our 5/3 squared. Okay. 5/3 squared. Right, so the easy way to think about completing the square is you take the, after you divide by the lead coefficient, and you move the constant term to the right-hand side of the equal sign, typically the right-hand side, the other side of the equal sign. Then you take the coefficient of the x term, cut it in half, and square it. Okay, but now notice that it's plus 5/3 squared plus 5/3 squared. We have to add that to both sides, right? We have to add that to both sides to keep our equation balanced. Now, notice from this step to this step, we now get x plus 5/3, that quantity, squared. Why? Well, because here we've completed the square. So that means that this can now be factored into two factors that are exactly the same, or a factor squared. And it becomes what? It becomes x, or whatever the variable is, plus the constant term, and that quantity squared. Now over here, what did we do? We still have the minus 2/3. Remember, that came from up here. When we move that constant to the other side, the 5/3 squared becomes 25/9, right? 5 squared is 25, 3 squared is 9. Minus 2/3 is really minus 6/9, right? To get a common denominator. So negative 6/9 plus 25/9 is how we get the 19/9. Okay. Now over here, when we use the general case to complete the square, notice what we get: b squared minus 4ac over 4a squared. Okay, and that's that should mean something to you, right? I'll show you that in just a moment. Okay, so let's read then what we've got here, because we're now at this point where we've got x plus 5/3 squared equals 19/9. Okay. We're trying to find out what x equals. Okay, so what do they say here? For every real value of x, the left member of the last equation in each column denotes the square of a real number. Therefore, this equation is solvable in the set of real numbers if and only if its right member is greater than or equal to 0. Since 9 and 4a squared are the squares of non-negative real numbers, they are positive. Hence, we need consider the numerators only. Okay, so let's look at what they did. All right, so 19 is greater than or equal to 0. That's obvious. So if we take the square root of x plus 5/3 squared, we get x plus 5/3. That means we need to square root the other side. So we either have the square root, positive square root of 19/9, or the negative square root of 19/9. Okay. Now notice over here, they're going to assume that b squared minus 4ac is greater than or equal to 0. So we take the square root, and you see they took the square root of each side. And they did the positive or the negative on the right-hand side where they're taking the square root. Well, there is a square root of 9, that's 3, but square root of 19, not sure. Right, so that's how we got this expression right here. Same thing here, there is a square root of 4a squared. It's 2a. 2a times 2a is 4a squared. So that's how they got this here. So now, with these, a positive and a negative expression, let's just combine them and do the plus minus here. We have negative 5/3, or that 5/3 from the left is moved to the right, negative 5/3, plus or minus square root 19/3. Now over here, the b over 2a is moved to the other side of the equal sign, negative b over 2a. We have the plus minus our radical over 2a. Well, now we have common denominators, so let's just write the numerator over a single denominator. We have negative 5 plus or minus square root 19 over 3. Over here we have negative b plus or minus square root b squared minus 4ac over 2a. Right? Over here, we see that we have two possible solutions. It all depends on whether the square root of 19 is positive or the square root of 19 is negative. Over here, we have the same circumstance, right? Now, what we just did, this right-hand column, what we just did was we used, in the general case, the process of completing the square to produce something special. Okay. And what we produced is told to us on the next page. And it says, do you see that 8x squared plus bx plus c equals 0, where a does not equal 0, is equivalent to the compound open sentence either x equals this or x equals this, which appears in combined form in the starred step. Look at the previous page, bottom of the right-hand column, just above where it says, but no, at the very bottom, or just above that, as the combined form, the negative b plus or minus square root b squared minus 4ac over 2a. This combination of linear equations is called the quadratic formula. To solve any quadratic equation, you may substitute the values of a, b, and c in the quadratic formula and find the root of each resulting linear equation. So now what you have is a particular formula that you can use. Okay, so here I'm given this quadratic, right? Oh man, I got to try to factor that. Will it factor? I don't know. No, you don't. You can use the quadratic formula. The a is 3, the b is negative 10, the c is 2. And there's your formula. Negative 10 put in for the b. Now notice, in the formula it's negative b, the opposite of b. Don't let yourself just write negative. If b is negative 10, don't just write negative 10, right? You're not substituting properly. That's why it's always best to substitute the value in parentheses, because that keeps the signs straight. So this is negative 10 squared, and then minus 4 times 3 times 2. 3 for a, 2 for c. Downstairs, 2 times 3. So look what happens here, and we end up with this as our answer. Okay, and so this is the quadratic formula. And so we have these two methods. We have completing the square. We have the quadratic formula. Okay, so on the next page, this is page 270 or 276, depending on your textbook. There's oral exercises, then there's the written exercises. So this is 7-8, and on the written exercises, I would like you to do 2 through 20 even. All right? Now 2, 4, 6, and 8, you're going to do using completing the square. All right? 10 through 20, you can use the quadratic formula, right? So for 10 through 20, you can use the negative b plus or minus b squared minus 4ac. I'm having to check right now. At one time I did have this memorized and I could just rattle it off quickly, but I'm checking to make sure I get it right. Okay, this is the quadratic formula. And you can use this formula right here for numbers 10 through 20 even. Okay. For numbers 2 through 8, you're going to complete the square. And completing the square is simply using the steps that we use to get to the quadratic formula. And so the 2, 4, 6, and 8, completing the square, are important to make sure you understand how the quadratic formula is derived. Okay? Remember, this is the magic machine for completing the square. Right? So let's look at number 2. We have y squared minus 4y minus 21 equals 0. Right? So the first thing we do is we divide by the coefficient on the squared term. The coefficient is 1, so dividing by 1 doesn't really mean anything. The next thing we do is move the constant term with its sign to the other side. And when we do that, as it crosses the equal sign, it changes its sign. Okay? Now it's magic machine time. We take the -4 and we put it into our magic machine, or we take half of -4. Half of -4 is -2. We square that and we get +4, right? But we have to add that to each side. All right, so now I know that here I'm going to get y, because that's the square root of y squared, minus 2, because 2 times 2 is 4, and that's going to equal 25. Oh, sorry, but y minus 2 squared is going to equal 25. So now I'll take the square root of each side, and that's going to say y minus 2 equals plus or minus the square root of 25. That is, y minus 2 equals plus or minus 5. The -2 I'll move over. That means that y equals 2 plus or minus 5. So that means my solution set is 7 if it's 2 plus 5, or -3 if it's 2 minus 5. And let's see how we did. I'm looking at the answer key, number 2. Hey, we got it. All right, so that's the simple process there. Now for the, once you get to number 10, right, what do we have? We have 5s squared minus s equals 1, right? So set it equal to 0. 5s squared minus s, bring the positive 1 across, becomes -1. And then note, my a is 5, my b is -1, my c is -1, right? Give myself a little space here. So we're going to substitute those values. So I'm going to take my quadratic formula right here, and -b, which is -1, plus or minus square root of b squared. This is -1 squared minus 4 times 5 times -1 all over 2 times 5. And I'm simply going to reduce that. Okay? All right, 7-8 is yours to enjoy.